Okay, so we are going to learn gas stoichiometry. So we are applying STP and non-STP conditions. Okay. So we know that we already learned the stoichiometry like last unit. We know that if you need to convert grams into mole, it will be what? It will be molar mass tan molar mass then divide with the molar mass times with the moles of A. And if you need to convert moles of A into moles of B, you will use a ratio and these numbers will come from the balanced equations. And if at STP condition, you can also use 1 mole is equal to what? 22.4 liters. Okay. So just we learned about STP, okay? We know that molar volume is 22.4 liter, which is the volume of 1 mole at STP condition. So standard temperature, which is 0 degrees Celsius or 273 Kelvin, and pressure is any of the unit, you can say 1 atm or use any other unit. Then all gases have same volume per mole, which is called molar volume, that is 22.4 liter. Okay, so this is the steps you are going to use at STP and non-STP condition. So if the temperature and pressure is 273 Kelvin, that is 0 degrees Celsius, or any of the unit, I'm writing only atm, you can directly convert the given volume into moles using 22.4 liter, then convert moles of A into moles of B. Again, same STP condition, convert moles of B into STP. That is a regular dimensional analysis. You don't need to worry about it. But if it is not at STP, you are not allowed to use this conversion factor. But we have volume given. We need moles, right? So in that case, you are using ideal gas equation. Just rearrange to find the number of moles. Okay. Then moles of A you will convert it into moles of B. Again we need volume and it is not at STP condition, so you have to use the ideal gas equation, rearrange it to find the volume and find this. So for advanced classes, most of your questions will follow this path. You won't get the direct stoic because you already know how to do it. Okay, so we have to check whether you know how to do this one. Okay, so mole ratio, again a review. This is ammonia, balance this, it is 2, 3, okay, 3 moles, 1 moles, 2 moles. The volume ratio, we know that if there is 3 mole, that is what? 3 times uh, 22. If we convert that into liter, like 3 moles will be 3 times 22.4 liter, right? Then this will be 22.4 liter and this will be 22.4 liter times 2. But it's molar volume, so their ratio will be always follow the mole ratios like this one. If it is 6 liter, this will be like double of that, then you can convert that into what? It will be 2 liter. This will be what? 4 liters. Okay, don't worry about that. We are going to calculate it. So these are the steps. Sometimes you will feel like, oh, this is too much, we don't want to read it. Then don't read it. Okay, let's go do some practice. I'm skipping these questions because we already did this question in class, right? So these ones are like non-STP conditions. So we did the same exact way like the highlighted one. So I'm going to do a different question now so that those who already have this one down, they will get the help from this. Okay, let's go do the practice question on page number 32 or 32 or 33. I don't know which one is difficult. I can't pick anything. Okay. Okay, 8 is, yeah. I want to do one grams question because that will be the most common one. Let's go find one. There's no grams question. It's given gram. It's given liter, given grams. Okay, let's do question number. Question number 31, page number 31. Okay, let's do question number 2. Okay, this one is given in grams. So if it is grams, you don't need to worry about whether it is STP or not, because mass will not be affected by temperature or pressure or volume, right? So we can directly start our T chart. So we go start 10.3 grams of Mg3N2. That is your magnesium nitrate, right? Then you will divide with the molar mass of magnesium nitride, and that is 1 mole of Mg3N2, right? Now you have mole. Then you will convert, the question is asking for ammonia. You are converting from this to this. So you will write 1 mole of Mg3N2 will produce 2 moles of NH3, right? Okay, now we have to stop here. We can't convert that into liters because the conditions are not at STP. So you have to stop there and calculate. You will get the moles. I think it is, didn't do the calculation. Moles of NH3. Okay. Now we need volume, right? We need to use this equation. If you want to rearrange it, you can rearrange or substitute. I always do rearrange that. That is V is equal to N times R times T divided by P. So N is 0.204 moles, and R value, look at the pressure, it is in millimeter of mercury. So you have to pick the value in millimeter of mercury, which is 62.4, okay, which is 62.4 millimeter of mercury. So we are going to write 62.4 L of Hg, then mole K times temperature. It is in 24 degrees Celsius, add 273, which is 293 Kelvin, then divided by pressure. Pressure is what? 752 millimeter of mercury. Okay, now multiply and divide and you will get the answer in liters, because if anyone is so curious about that, mole and mole we can cross, millimeter cancel, K and K cancel, so the only unit remaining will be liter, so you will get the answer in liters. So it will be 5.03 liters. So that's how we are doing gas stoic and